Today is 21st of January 2026. The time now is 22:04. I was doing computers, but you know, I have a bipolar side. I have a tripolar, so I have three sides to me. I'm three lenses, but today video is literally about neurodivergence. But I have to speak up here from my own angle. So this is a Zen kind. I'm following Zen kind on MSM, but it's basically about the open sexual creativity, weaponry, everything. Okay, so my three hypotheses. So I am autistic. I'm neurodivergent. I'm proud of being autism. I am from Nigeria. I don't have a disability. I have neurodivergence. But I have to start disclosing why things happen. Things happen. So, change.org/obnexus_reform. O for Oscar, B for Bravo, I for India, N for November, E for Echo, X for X-ray, U for Bella, S for Sarah, _reform, R for Romeo, E for Echo, F for France, O for Orange, F for R for Romeo, E for Mike, the Urbanist Reform. I'm literally building my own legislation through that, which is health and enablement, not health and social care. There's no health and social care as a foreign problem, no social care, no caring for people in my constitutional framework of OB Nexus, because I made this thing, and I've only Article 51 declared Article 51 declares sovereignty from the UN Charter. So basically, this Article 51 is right to self-defense, which is the country to legally abide them. Because you got a business structure, you got a constitutional model. But this is basically my social care reform, my reform for health for neurodivergent people via OB Nexus. Literally, you have my motto is when systems fail, build their own, and I did just that. And I did just that, which is a dash because that's the tagline, But I'm talking to you guys now, what do you guys want to do, neurodivergent people, like in Nigeria and Biafra? I want you guys to have houses free of charge. I want you guys to know Nigeria doesn't have a support structure for neurodivergent in every shape or form. We have a Mensa, but Mensa is going to give you a lot of problems. So I am not just moving from a problem. I'm trying to divide and conquer. But I'm not a king. I'm not a king. In the futures as well. But my granddad is a king, but great granddad is a king, but not my dad. My granddad is a king, and my granddad is a king, but not me. I don't want to be. My dad is not a king as well. So, but in that kind of sense. So as you can see here, you can see my document I wrote up today, very poorly, of course. 3 days. So I'm going to speak about my autism, ADHD, Asperger's clearly now. But let's start with the things to get the way. So this thing to get my hypothesis here. This I'm going to get away. So the first one I'll address is the blueprint. So hypothesis to prototype a self-ontological weaponry stationary system that serves different sovereignty, human rights via separation of concern, and honor the wielder in combat. This is my hypothesis. But hypothesis is just not. This is not hypothesis. This is an objective. But this is framed as a hypothesis because I already got it down. So a blueprint for structures and shape. So that respects the way, shape, and form of a Mmuko holographic signal with a no-lock memory. So the first one means the hypothesis to prototype a set of ontological weaponry stationary system that serves Biafran, which is Biafran means come and take, sovereignty, human rights via separation of concern, and honor the wielder in combat. Basically, this weapon is not for killing people, it is past weapon system. The term ontological means from Biafran history, weaponry for things basically how we build stuff in the past. Because a lot of weapons are rubbish, they're rubbish. So because I'm being busy, I reinvented with geography, because I saw potential in it. But because of the kind of safety around internet and because you can have radio internet, you can have radio Bluetooth. The goal of that kind of thing is basically the same thing for the weapon system. But it's a weapon system force past defense via sovereignty of organisms. But I'm trying to do it, but if anybody has an idea, just pitch it in. I don't care how stupid it is. You like the idea, you have an idea, you pitch it in. And that's what I need you guys to do. This is basically the OB Nexus pitch initiative. You pitch your ideas, because I want you to pitch your ideas. So you guys, I'm making decisions because I'm not crazy. I'm just saying yes, you guys do it because we need it, guys. We need it. I don't, that's gonna get 50 people building weapons again safely of course. I don't care any child that could build a weapon. But for 15 years old, if you're not in it to win it. You have to start doing it yourself. So it doesn't matter. So I want to build weapons. I want to build weapons as a child. Ever since I met a born arrow in Nigeria, I wanted to build weapons. But the system didn't allow me to do because I didn't have the resources to do it. I didn't know the know-how, but the know-how then. So by now I had the prototypes already on paper. So it goes to this level to build. So the intelligent weapons, and the system that serve sovereign interests of human rights, our human rights. I have 18 human rights, so there you go. Then, he didn't serve my human rights. He has to must protect and serve my human rights, not me, my human rights before it serves me. So the weapon must serve me first, and that is me. I'm a human rights first. But depending on how you look at it, so for example, I have 8 plus 8, 16 human rights, and then 8 times 8, 64. So the weapons must serve me and protect me in combat. We got a weapon and shield. I love the shield, but basically, I am giving you the model of a protection system of this kind of loader system. So the second one, a blueprint via structured and structure and shape, way, shape, and form. So this is M for Mike, U for umbrella, K for kilo, O for Oscar. Mmuko sense single no lock. No lock. So this is a no lock. So basically, you got the lock and your lock interface. So how does Mmuko OS boot? How does Mmuko OS boot? So when Mmuko, my fucking pen. I have to give you a detailed breakdown of this thing. So Mmuko OS boots by in a very unique way, and in a very good way. In a way that you love to do. So the Mmuko OS, just say you have an array of bytes, not array of bytes, but array of binary of 8 bits, 8 bits. So 8 bits, 8 qubits. But superposition of 8 qubits. But this 8 qubits and superposition, so you are trying to, the goal of this superposition is to have an axis. So each one has a span of a half. So you have pi over 3, pi over 2, and pi over 1, pi over 3, pi over 4. You get pi over 4, which is 90 degrees. Pi over 3, which is 180 degrees, minus 180, and then you get pi over 3, which is 370, pi over 4, pi over 2, which is 270, and pi, which is 360. So this is one. But each qubit is actually have a spin up and down, up, down, up, down, charm, strange, and all of them left, right, via the tour, the lapis, the tour, which is so you got the lepton, then you get the muon, then you get the tour. So the lepton is you have to take you have to measure it to 10th. A tenth of the measurement of a lepton is 1 divided by the ton of the spin. So you have to take a tenth. So a tenth of the measurement. So if you have 10. 1 over 100, 1 over 1,000. So, so Mmuko OS is a non-polar, non-linear system. So a lepton, if you have a feather and an atom in a medium of no air, no water, no gravity, in a medium of a vacuum, they will fall at the same rate. A hammer and a feather, they will fall, because not even the gravity, if it's only gravity, they will fall because there's no other factors affecting it, like the wind or the air. There's no just gravity. The medium of gravity creates equilibrium between the feather and the hammer, and the hammer, is the same medium. So they have to share the same medium, but they fall at the same rate because there's no thing. But this is what the gravity is. So 9.8 meters per second is that measurement. So 9.8 meters per second is that measurement. But a tenth of this is what it should. This should a tenth. So a tenth of this would be 0.98 of a lepton. 0.98. So how does Mmuko OS boot? Is literally 0.9. So you get 0.98 as a lepton, 0.098 as a muon, and 0.0098 as a tor. So you get L for Lima, E for Echo, P for Papa, T for Tango, O for Oscar, N for November, which is the lepton. So this is 0.98, which is a feather and the kind of hammer. And then the new one, M for Mike, U for umbrella, O for Oscar, and O N for November is 100. 1 divided by 100. So 1 divided by 10, 1 divided by 100 is the measure. So this is gravity only acting alone. So this here is 0.098 meters per second. So, in the area of in the space of squared, in the area of no gravity, and the torque 1/1000, which is a thousandth of the measure. So therefore, really slowly, because everything is gone. You know what I'm saying? So how does Mmuko always boost? Mmuko always boosts because way, shape, and form of some via new divergence projection matrix. So say everything has a polar configuration, which is a half. So you get a 0, 0. So you have the first byte, the first bit. You have to think of two. You have to get everyone aligned in the middle from their frame of reference. So basically, the number, everything is a bit here, only 8 bits of boot sequence. The boot sequence. How Mmuko able to boot is you get a half. So everything has a spin of a half. Half in one axis of direction. So it doesn't matter where they are, they have to be facing, they have to be in the medium of half. It doesn't have a spin of a half. So, so if you have like 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 1, 2, 3, 4, wait, 8. So medium, 1, 2, 3, 4. 1, 2, okay, 1, 2, 3, 4, 5, 6, 7, 8. 8 qubits. 8 qubits divided by pi. So basically, if there must be in the medium half, and that half is pi over 4. Pi over 4. So if pi over 4 times 8, basically not 360. So just do my cousin. Pi over 4. Pi over 4 times 8. So it's times 8. And now this will give us 6.2831. But this is just a medium of this application. So you get the mode, medium, range. So the mode is the most common number. The medium, the range, the medium, mode, medium, range, the mean. So the mean. So if you get all the bits added together, let me give you a binary calculator. So if you get the binary calculators, you get the number 1, 1. So if you get the number, so it's really, if you can have the number 8 bits, how many numbers can you make up? So you have to think about the numbers. The numbers you can make up with 8 bits is 0, 1, 2, 2, 4, 8, 16. You go 0, 2, 4, 4, 6, 8, 12. So you get 1, 2, 3, 4, 5, 6, 7, 8. So you get 1 to 12, no 1 to 12 indexing. Yes, sir. So if you have 6, if you have the middle number of 6, 1, 2, 3, 4, 6, 6, 6, 6. The number 6 in binary is 1, 0, 0. So 1, 0, 0, 0. 1, 0, 0, 0, 0. 1, 0, 0, 0, 0. Okay, 1, 2, 2. 1, 0, 0, 0, 0. 1 and 4. Yeah, so number 6, so 1, 0, 0, 0, 0. Basically, times will give you times pi divided by 2. And pi divided by 2 is 1,000. So 1,000 here, but it's a binary number, enter, is 1,000. So 1,000 divided by 2, 1,000 divided by times pi times 4 times 4. So this is an 8. So this is an 8. This is not. This is an 8. This is not 1 and 1. So this is 1, 0, 0. So you get 0, 1, 0, 0. Oh, this is 6. So this is a 6. This is an 8. This is a 4. So 1, 0, 0, 0. So this is a binary number here. 1, 0, 0. This is 10. 0, 1, 0, 1. So 0, 1, 0, 1. 0, 1, 1, 1. 0, 1, 2. So basically, the number 6 is okay. So you get 4. 6. So you get 4, 4. No, it goes with the, so it goes with 2. So 4 times 2 is 4. Times 2 is 8. So so you get the number 4 plus 2. So you get 1 1 0 0, and that will give you a 6 1 1 0 0 14. You get 0 1 1 0. So 0 1 1 0 0 1 1 0. So that basically mean 1 2 3 4. So you get 3 and 0 1 1 0, because it's like it's a positive number. So you get so you get 6 number. This number was 6. That's what happened. So 6 times, so 6 divided by pi, divided by pi. So okay, 6 divided by pi. There's no sign. Right shift 4. Right shift 3 3. 0 1 2. Right shift 3 will give you 0. See, basically, basically, as you can see, I take the number 4 and I right shift the number 6 and I right shift 3. 3. So I go 0. So in binary, I go 0. This is basically a 1 4 rotation. So basically, because I go the number 0 modulo, I don't with this. As you can see, the number 6 modulo 3 is 0. Modulo right shift 3. Right shift 3 is the same as modulo 3 in 0. So it gives me 0. And the 0 is basically the because I did right shift, not a left shift. If I do a left shift, I will do 0 1 1 0 left shift. Left shift 0 1 1 1 no 1 1 1. So that was 0 1 1 1 0 1 1. So 0 1 1 0 0 1 1. So 0 1 1 left shift 0 0 1 1 will give me 60. So basically, that's the total space I have for the but I'm right shifting because I'm removing back. I'm trying to remove stuff from something from the bit marks. The bit shift and the bit mark. So you get the logical arithmetic shift. Now we've got the rotational shift. Now we're going to do, so basically you got the with this, so the total, so 0, here we do 0 1 1 0, and the rotate right 0 0 1 1. You get 11. But this is 11, it's not. So basically, the goal of this is to have an access system that models this properly. But my computer boots and works because everything is aligned to center. If you don't understand what I'm saying, you gotta think of it more non-sequentially. Think of it like you are having this kind of graph system here, the graph here, and you're literally trying to you're literally just trying to give anything this point in space and time. So every qubit must be able to have a space and time. It's going to because it has a spin. Every number has a spin, and that spin is a convolution that's tomographic, and that tomographic has an area, it's a space for itself allocated already. So if it's a compass, and the compass model is basically a number it has a location, it's point if the direction is facing, and when it's facing one direction, it's not facing any more directions, and that's what I'm saying. There's no direction. So if I use a scientific calculator, which is not a standard calculator, I can do literally 6 divided by 4. No, 6 times. No, 6 divided by 3. No, 6 divided by pi. And this number 6 divided by pi is number 6, and it's 1.9098 6 or 85 going 86 times 4, and this will give me 7.63983. No, I'm doing it wrong. So this is times. So I'm doing the number 6 times pi divided by 4. If I times by 6, I'm getting. So if I times by 4 first, I remove the 4, and the 4 becomes with the 6. So 6 times 4 will be 24. So I times 6 times 4. So 6 times 4, and this is a fraction ratio, which is 24. Basically, what's the fraction ratio? 6 times 4 is 24, and 24 is definitely to divide by pi. Which, it's basically, I'm balancing the multiplication. So if I do pi divided by 4, pi divided by 4 has an opposite, which is not 4 divided by pi. But, I'm trying to eliminate the minimum, I'm trying to remove something, if I'm, the opposite, so 4 divided by pi is basically 4 divided by pi is not pi divided by 4. And, so this is a unit measurement, but I don't want 1.727, I want something, because if I'm in this unit, that means I'm just facing it, I'm never moving. I haven't moved a bit, I haven't rotated. So I want to, but you use a fine state for the system. But if I do pi for pi divided by 3, we have 1.0471, and we have pi divided by 2. And we have 1.570, and we have pi divided by 4. 0.785. Okay. I've got pi. So the number of pi divided by 4 is basically the rotation. So this is spin. So if I do pi divided by 4, I get 0. And I do then I do times the number. Times something. This pi divided by 4 is an accessory times a number. A number is a binary number. So a binary number will be in binary will be 12 or 6, which would be in the whatever. But because to have the mode medium and something in system, so the system can know the age of this. So if the number is 12, let's say the number is 10. 8, the number is 0. Basically, sorry. So 0, 1, 2, 3, 1, 2, 4. I see what I made 6, 8, 8, 7, 7. Because it goes in twos. It's 2 comes in twos. It's not doubled. I've got that. So the numbers times. So 0. Get 1 to 0. 1, 2, 4, 6, 8, and that will be 6, 8, 10, 11, 12. 1, 2, 3, 4. So if I get the number 6, 7, 8, 9, if I get the number 9 times 9, the unit of 9 will be over the pi actual 5 divided by 4. This pi divided by 4 is not pi divided by 3. It's 7.606. So if I do pi divided by 2, which is now the opposite spin, pi divided by 2. But think of it, if you don't understand what I'm saying, think of people lining up for some kind of system, and they're facing one direction, but they're all facing one direction, one direction. But that direction is either north, east, south, west. Then now you have to take one person and rotate them north, and all the other people rotate them from north, rotate one south, and that person south is a new middle, but that middle is not there. So basically, they can't move in the middle because they are just in a state of lock. So that lock is basically they have to now act on the observer. So they have to now be the center of the show. Basically, either everyone gets behind this one person to make a straight line, or the other way around, or the person just faces the line, joins the back of the queue, and just faces the other way, which is not the goal. The goal is to have this work for everyone and anyone that is based on topography. So the facing is the compass, so it's the needle of the compass, and the compass faces one way, and it doesn't have to move. You have to move, and that compass updates for you. So if you're not moving, there's no update for you in your frame of reference. I'm saying. So I'm saying to you, so you get the wage perform formula. So that's how it works. So if like 8 people are facing any direction, any axis, they have a center, and that center is basically is half the dimension. So if I have 8, so for example, if I have the best way to do it is to start from the how many bits in a byte. So the number, so highest number you have the one is the highest number you have in so let's do it again is 1, 2, 4, 6, 8. 1, 2, 3, 4, 5, 6, 7, 8. So the number 12 is the highest. 12 divided by 2 is 6. That will give me the number, this number 6. But I have already looked up I'm using this dining table to go to this. So this is a lookup table I'm doing. So I'm trying to find out where everything is in my frame of reference. So if I go to the binary number of 12, because it's 1, 2, 3, 4, 6, 7, 8. I have a lookup table. So I'm using lookup table to solve this problem. Lookup table is here. So lookup table will be the number 12 is on the farther side, on the other side. So it's not facing, it is not facing north. It is north. It is facing north. But I have to flip it. If I flip the north, I make it face north. I make it face opposite north, which is I make it face opposite north, which is northeast south, which is west. I make the number 12 face west. So the speed for that will be a half. No, will be northeast southwest. Will be a half. So would be a half speed. No. Pi divided by 3, no, pi divided by 2, no, pi divided by 4, pi divided by 3, be pi divided by 2, pi divided by 2. And pi divided by 2 is the goal of it. So pi divided by 2 is the number 12 facing opposite way. And this number 12 is facing one way of 12, so it's facing south. And now I know that I can teleport, I can be in a superposition of north and south. So if I have a north, I have a south. So everything must be in a superposition, must be entangled, and must not interfere with each other, deconstructively. That has to go, because they're really entangled. So north, if you get north, you get south, you get the system resolve the states independently. So that's the good sequence. That's it. So the half, south. If you're facing south, you're facing pi divided by 2. Pi divided by 2, and that is south. Now, if you get south, you get the middle. 12. So 12, so if you start from 12, so the middle of 1, 2, 3, 4. So you start from the middle of the small subsets, or you have to use diagonal progress. So basically, you can't just go to the middle of the big thing. So you can calculate two numbers. You can get two numbers. You can get two. So if you have the medium of meters, so if you get the mode, which is the middle number, all the numbers added together, divided by how many are. No, the most common number is to come to average. So the mode, medium, range, and the mode, median, range, and mean. Means all the numbers added together. So you get the mode. So the mode is the most common number. The mean is on the way. So you have to come with the ratio. So you can do the standard deviation. So you can do range. So the mode, median, range. So you get 4. So you get 12, 10, 8, 6, which are the indexes. So the binary indexes of the bases. So they work on bases. So basically, this basis has to be reduced to the numbers, and this numbers it's basically working on the basis, not the numbers itself, because these numbers can be in a superposition. So it computes two states. So if I've computed 12, which is south, that means it's a number, something I'm computing south. I do some operation. So 1, 2, 3, 4, 5, 6, 7, 12. So you start at the end, but there's the middle, and there's a middle between and that's the 6. 6. So I hold 6. So 6 will be facing either can be in a superposition. So the number 6 can be in a position of east, northeast, south, west. No, east. No, northeast, south, or west. So this superposition, the base index 6 will be at the superposition of southwest, and that's the computer piece. Basically, the number 6, the base 6 is like a number that can repeat this process. So the goal is to have a dynamic table to look up the index of the bases. So the map, which is a weak map, which is like a boot map, which we call a weak map, maps the indexes to the superposition over some of the. You want to be able to have a rotation of 360 without any problem, which is quantum spin. So you get superposition. So the number, so this is now entangled in the quantum state they are via a serial step. The sequence. So you have to have double the time and double the space and half the time in memory to do that stuff. Because you can observe both things. So you now have to put 6. So if I've then allocated south to 12, then I've allocated you go to number 6. Number 6 can be allocated to something, and that will basically be either west or south. So we can use south. We can use west, because west is what? Pi over 2. Pi over 3. And pi over 3, so you get number pi over 3. You get the 1, which is the 1 which is pi over 4. Then you get south, which is pi over 2. and you get west, which is pi. So if pi over 3 is 6, we can be 6, can be both ways. Then you can have the number something. So you get 6 divided by 2. So you get 6, you get the number 3. Now, 3 is not there. So number 3 is just an odd number, but it's very there. So number 3 is there. So the number base 2 is there. So this is the average. So you get number 6. So you can think of number 6 items, but in the house. So you can either go back or 6 power to the power times 2, which is the 6. Because you have to half to the power half to half. So if you go to number 3, 3 can have then 3. So 3 can now basically it's a non-linear system that shows you get because this is basically a camera thing. So basically it's non-linear because every number is in an array, and the array makes sure it's safe, and the array works because it's an index system. So it allows you to index data that is via power rules. Polar power system, because the polar system, that's the system with Mmuko always beats. So let me go now.